Okay, so in the previous video, I asked you a question, pretty simple question. We made a probability distribution table using pivot table function on Excel, and then I asked you how many outcomes in this sample space. The answer is 4, because when you choose one person, the person will be either one of these 4, will answer with one of these 4, right? So it is 2 by 2 table, so you are going to see 4 different types of answers. Similarly, if you have like this kind of, let's turn off blank. If you have 4 by 4 like this, then there are 16 types of people, right? For example, black in North Central, black in Northeast, Hispanic in North Central, Hispanic in Northeast, like blah, blah, blah. This way, there are 16 types of outcomes. And in this case, simply 2 by 2. So the answer is 4. So there are 4 possible outcomes. Why is it important? If you have 4 possible outcomes, that means if you know 4 probabilities, these numbers, then you know everything. You can tell, you can calculate probability for any kind of event with these 2 variables, right? I'll show you. So far we considered 4 outcomes, but as I said, event is different, and the probability of an event can be simply said to be the sum of probabilities of the outcomes that are included in that event, right? For example, if you think of an event that includes these 3 types, 3 outcomes, then you can simply sum these 3 probabilities, right? So it doesn't matter how you make up an event. As long as you have this 2 by 2 probability table, then you can calculate the probability. It is pretty simple. The idea is simple, right? So, okay, then let's make it more mathematical. So we are going to define notation for events in this example. First, I'm going to define the basic events using each of the variables. Like here, F stands for female. So F is based on gender. And H stands for having a health insurance. So it is based on the health insurance coverage variable, right? So you can then we denote the probability in this way, like a function. So probability is a function from an event to a number, right? So if you input an event, then the output from the probability function is its probability, right? So PRF means probability of event F, and this means probability of H, right? So then, now what I'm going to show you here is any event based on these 2 basic events can be expressed as using only 3 operations. So I will show you one of them. The 3 operations we are going to study are complement, union, and intersection. So these are the operations you learned in middle school or high school about sets. When you have different sets, you can take their union or their intersection, or you can take complement of a set. So we are going to do the same thing. First, we will study complement. So female was denoted as F. Then how can we define male? Pretty simple. Male, in our data, male is the set of all outcomes that are not in female in our data set. All right. So in other words, female is the event that F does not happen. So, right? So it's the complement. If F does not happen, then male happened, right? It's 1 or 0. It's yes or no type question. So if not female, then of course it's male. Then we call this complement of female, complement of an event, and we denote it as the event superscript C. Of course, C stands for complement. So similarly, H stands for those who have health insurance. Then those who do not have health insurance can be denoted as C superscript complement. Excuse me, H complement C. H superscript C. So again, statistically, you can think it as an event where H does not happen. And H means when you choose a random person, if the person has health insurance, then event H happens, right? So then when H does not happen, means a randomly chosen person does not have health insurance, right? So complement is pretty intuitive. And then here, let me ask you, what is the probability of F complement using mathematical notation? Should be pretty easy. Okay, so stop the video if you have not finished your computation. Okay, the answer is, so first, so to see this probability, the answer is the sum of these two numbers. Because first, F female is an event that includes actually two outcomes. It's not a single outcome. Female includes, among 4 types, female includes female those who don't have health insurance, and female who do have health insurance. So includes 2 outcomes, 2 types, but we take its complement. So everything but these 2 types. So that goes to the other side. So these 2 outcomes fall into this event, F complement. And then you know there are 2 outcomes, then the true probability is sum of these 2 probabilities. Which is obvious, right? And then that means and then from there you can derive complement rule. So for any event, there are only 2 cases, whether A happens or not. So if you think about A, it may happen or not. So, and also we know that the probability of everything should be 100%. Always, the total probability should be 100%. So as a result, the probability of A happening plus probability of A not happening must sum to 100%. In other words, then if you move this term to the other side, the probability of complement is easily calculated as 1 minus probability of the original event. So that's pretty obvious, okay? Next, we are going to study union. So union is OR. Connect 2 events using OR connection. So like for example, suppose that you are interested in female or having a health insurance. So if you choose a random person, what is the probability that the person is either female or having a health insurance? Then you can denote it as F union H. Often this mathematical symbol is called cup. F cup H, right? I don't know why it's called cup. Later, intersection is called cap. It looks like a cup, so it's called cup. So then you can also interpret this as at least one of 2 events happens, and we call that union. And like in this example, female or having a health insurance includes 3 types among 4. That means the only excluded type is male who do not have healthy insurance. Other than that, they satisfy at least one of the two conditions, being female or having a health insurance. So also pretty easy. And then the probability is sum of these three numbers, three probabilities, three simple probabilities. Okay, now then you do it by yourself. What is the probability of health insurance cup like F cup H? Excuse me. Just try it. I have already gave you how to do it. So the answer is sum of these three numbers. Then we have 80%, 80.11%. So the answer is pretty simple. Finally, the third operation is intersection. In this case, we connect two conditions using AND. So, for example, we are interested in female who have health insurance, right? So, a person, when you choose a random person, the person should satisfy two conditions at the same time. Should be female and should have health insurance. Then if those two conditions are satisfied at the same time, then this event intersection is intersection happens. Both two events happen together. That is intersection. We denote it as F cap H. So it looks like a cap. So F cap H, F intersection H, stands for intersection. And in this case, female and having a health insurance have an intersection here. So these two types satisfy female condition, and these two types satisfy health insurance condition. And intersection includes those who satisfy both. So only these people, 36%. So actually, I have to ask this as a question, but I did it. Okay, so we learned three operations. I believe it's pretty easy for most of you. But also, you may wonder why is it important? Why do we bother to think about union, intersection, complement? So mathematically, I'd say it this way. So they are called mathematical operations. You are manipulating events, sets. And like for numbers, you have learned a lot of operations. Addition, subtraction, multiplication, division, and then you learned logarithm, exponents, and like say square root, and what else? Like you learned sine, cosine. Like there are numerous operations for numbers. But think about this. For sets, you only learned 3. So that means, and mathematically, there are only 3 operations. That's it. And the information theory is a field of statistics studying the how to code information, how to efficiently transmit information, and according to that information theory, these 3 operations are enough. Like the 3 operations can make up any information you want, given the knowledge. So if you ask me why do I have to study these 3 operations, then I would ask you back. You learned only 3. That means they are everything. Then why don't you just study 3? It's enough. If you want to study more, then you'd be more sad. So you are lucky to have only 3, and they are super powerful. That's all you need in your life to study sets. So I'd like to say that because a lot of students wondered why they are important. They are important because there are only them. Okay, this is end of the third video, like fourth, and I'm going to, in the next video, I will derive a formula based on these operations. So they will, and yes, I'm going to see you in the next video. See you later.